Okay, in this video we're going to be going over strong acid and strong base neutralizations. So these ones are going to be applying all the principles we learned earlier, and we're going to try to figure out what molarity we need to neutralize this solution. So first step is looking at what they're giving us. So they're giving us the amount of liters of HCl and the molarity of the HCl. So in all of these reactions, we know that the moles of base equals the moles of acid in order for something to be titrated or neutralized. So let's figure out how many moles of HCl we have. And we got to convert that to liters. And when we multiply that out, we should get 0.2 times 10 to the negative 3. Okay, and we know that's the number of moles of base that we must have in order to neutralize that. So let's figure out our moles of base. That's just going to be equal to this 0.2 times 10 to the negative third. And then they're telling us that we have 45.3 milliliters of that. So let's convert that to liters. And then what we're looking for is molarity. Molarity times liters is going to give us moles. So now let's solve for the molarity. And that should give us 4.415 times 10 to the negative third molar. So let's check our significant figures. We have one too many. So 4.42 times 10 to the negative third molar. And then that's our molarity of HCl, of KOH actually. Okay, so that's a simple one, and you might have noticed that you probably could have just used the equation M1V1 equals M2V2. You could have, but I like to work it out this way so you can see each of the steps. I like to, at least in the next problem, you'll see that we can't just use this right off the bat, and we'll have to use something different. So the next problem we have H2SO4 and we have lithium hydroxide. So we need to figure out the molar concentration of lithium hydroxide, of H2SO4 actually, and we have everything we need to find the moles of lithium hydroxide. So in these ones, it's best to write out the actual dissociation equation as we did before. Okay, but in this case we have 1:1 ratio, so we don't have to do anything special here, so we can just find our moles of hydroxide. And we got to convert our milliliters into liters. And when we do that, we should get 8.50 times 10 to the negative fourth, 500 moles. Okay. So now we can move on to finding the moles of H3O plus. And those just equal the moles of OH minus. And we know what that is. It's 8.500 times 10 to the negative fourth. And what we have is we have the equation for H2SO4. So let's write that out. And since this one's a strong acid, we write the single bar. And since there's two hydrogens and it completely dissociates, we put a 2 in front of the H3O plus. Okay, and now notice that we have a 1 to 2 ratio. So we're going to incorporate that ratio into our solving of this problem. So we have 0.5 or 0.050 liters of H2SO4, and we have 2 H3O plus per 1 H2SO4. Now what we're looking for is the molarity, and we multiply that by this stuff so it equals the moles of base. So now we can solve for the molarity. And then this right here just equals so our molarity is just going to equal 8.5 times 10 to the negative 3. So as you can see, it was important that we write out the dissociation equation, because otherwise we would have been off by a factor of 2 in our answer. So always make sure you do that, and you'll get the problem right every time.